So have you ever felt like you're just completely stuck in a loop with your AI? Like you're constantly reminding it of who you are, what you're working on, how you like things formatted?
Oh, absolutely. It's like Groundhog Day every time you open a new tab.
Right. Well, today we're doing a deep dive into something that breaks that loop. Because right now, somewhere on a server, there's an AI literally writing an operational manual for itself. It's not sitting there waiting for a human prompt.
No, it's actively working.
Yeah, exactly. It hits an execution error, analyzes the stack trace, rewrites its own logic to fix the bug, and then saves that solution as a permanent skill it will never forget. So our mission today is to explore this massive leap from static AI settings to true autonomy.
Yeah, we're unpacking a self-evolving system known as the Hermes agent. And I mean, let's be clear up front, this isn't just about tweaking your prompts to get, slightly better chat responses.
No, not at all.
We're looking at a system that actually learns your style, builds its own bespoke tools, and compounds in value over time.
Which is wild. But to really appreciate why a self-evolving architecture like Hermes fundamentally changes the game, I think we first have to isolate the exact pain points of the current landscape, right?
Right. We have to look at the bottleneck. And right now, the entire industry is bottlenecked by this condition we can call session amnesia.
Session amnesia. Okay, so break that down for us, because every time you open a new browser tab, you're essentially starting from absolute zero.
Exactly. You spend tokens establishing the environment, defining the parameters, maybe doing some trial and error troubleshooting just to get the AI calibrated to a specific coding task.
Yeah, you paste in your huge system prompt, you argue with it for 20 minutes, and then you finally hit a flow state.
Right. You get it working. But then, the browser closes or the session ends and bam, the context window is completely wiped clean. All that logical trial and error context is just gone.
Which is so frustrating because the AI doesn't just forget the code you wrote, it forgets like why you wrote it that way.
Yes. It forgets the dead ends you both agreed to avoid 10 minutes ago.
It's basically the equivalent of having this brilliant top-tier human assistant, but their memory gets completely erased every single time you close the office door.
That's a perfect analogy.
Right. You have to spend an hour every morning re-explaining the company's core mission before they can do like 5 minutes of actual deep work. Users are just trapped manually retyping prompts.
Yeah, they're stuck in this state of passive configuration. And since being stuck in passive configuration is a complete dead end for real productivity, we really need to look at the architectural shift required to fix it.
Right. We need a paradigm shift from configuration to actual autonomy.
Exactly. And Hermes represents that shift by completely abandoning that old linear model of, manual input, short-term session, and then reset.
So how does it operate instead?
Well, it's 100% open source, for one. But more importantly, it acts as a 247 VPS resident. It lives on a virtual private server, constantly active. I really want to emphasize this distinction. Hermes is not a chatbot.
Right. It's not just sitting in a browser window waiting for you.
No, it's a 247 resident digital co-founder that literally writes its own operational manuals.
Okay, wait, let me push back on that term slightly. Because calling it a co-founder implies a pretty high level of independent agency.
Sure.
I mean, I have monitoring scripts and like cron jobs running 24/7 on my VPS, but I definitely don't call them my co-founders. So what separates Hermes from just being a persistent background script?
It's all about the anatomy of its digital brain. Specifically, its four-tier memory architecture. If Hermes is going to act as a co-founder and cure that session amnesia we talked about, it needs a serious memory upgrade.
Okay, so walk us through the 4 tiers.
So tier 1 is session memory. This handles the immediate, short-term contextual conversation. It's basically the standard working memory of your current interaction.
Right, that's familiar territory. That's what we have now.
Exactly. But tier 2 is where the architecture really pivots. Tier 2 relies on an SQLite database for project data and queryable state tracking.
Oh, SQLite. Now that is interesting because the entire AI industry has been completely obsessed with vector databases for the last, 2 years?
Oh yeah, everyone's all about semantic search and embeddings.
Right. So why on earth would a cutting-edge agent rely on a traditional relational database like SQLite?
Because vector databases are excellent for semantic similarity, like finding a document that kind of sounds like what you're asking for.
Yeah, close enough search.
Right. But when an autonomous agent is navigating complex code bases or managing a massive project, it doesn't need semantic approximation. It needs strict deterministic state tracking.
I see. It needs facts, not vibes.
Exactly. Hermes needs to know the exact absolute path of a file, its exact timestamp, its precise relationship to other modules. SQLite provides that rigid structure so the AI never hallucinates the state of your project.
That makes perfect sense. Because approximation is super dangerous when you're executing actual code.
Exactly. So we have short-term memory and we have strict project state tracking. Then we hit tier 3, which is called Honcho.
Honcho, okay.
Yeah, Honcho is the meta context.
Wait, so Honcho isn't just remembering facts about the project, it's actually learning my coding style.
Yes.
Like, it remembers my preferences. Say I prefer writing in Rust over Python, it just knows that.
It absolutely knows that. It observes your idiosyncrasies. It tracks how you format your doc strings, your preferred frameworks. It analyzes the delta between its initial proposals and your final accepted commits.
Oh, wow, so it's actively studying me.
Right. Over time, Honcho builds this deeply personalized statistical model of your interaction patterns. If it's just a Python script and you constantly ask it to refactor into Rust, Honcho just updates its meta-context payload.
So next time, it doesn't even bother with Python.
Exactly. It bypasses Python entirely. It creates this highly personalized experience where the need for you to explain yourself approaches zero.
That is incredible. Okay, so memory is clearly only half the battle, though, right? Like,
Right.
an AI can remember my preference for Rust, sure, but how does it actually learn to do new complex tasks without me holding its hand?
That gap is bridged by tier 4, the procedural skills, and what we call the evolution engine.
Right, the autonomous self-learning loop.
Exactly. It's a 3-step loop. Step 1 is action and error. So the code executes and it fails.
Because it's trying something totally novel.
Right. It attempts to write code for a new problem, it breaks, and instead of halting and asking you for help, Hermes captures the complete error log.
Okay, let me jump in here and play devil's advocate for a second. If Hermes is writing its own code to fix its own errors, what stops it from getting caught in, like, a massive hallucination death spiral?
That's a valid concern.
Right. We've all seen LLMs write bad code, get a weird traceback error, and then just hallucinate a fix that fundamentally breaks the entire script.
Yeah, it deletes the database or something.
Exactly. How does Hermes avoid setting the server on fire in an infinite loop?
It avoids the loop through strict deterministic testing. That's step 2. AI self-correction. When Hermes parses the error log, it isn't just wildly guessing. It isolates the specific line of the stack trace, cross-references it with official documentation that it pulls in real time, and then modifies the prompt in the code to fix the failure.
It's using the compiler as a rigid reality check.
Exactly. It's almost like genetic breeding of code. It mutates the code, iterates, and evolves it until it survives the runtime environment.
That's such a great analogy. It's like a human developer sitting alone in a dark room, compiling code, reading the error log, tweaking one line, and rewriting it over and over until it works perfectly, totally unassisted.
Yes, but doing it at machine speed. And once it survives, we hit step 3, skill creation. The perfect error-free run is permanently saved as a standard markdown document, an agentskills.io file.
So it's a permanent .md procedure saved from a successful run.
Right. It essentially manufactures its own custom tools on the fly.
Okay, so now that we know Hermes is this hyper-focused, self-correcting builder, we kind of need to understand where it fits in the broader AI ecosystem. How does it compare to other structural models out there?
Yeah, the evolutionary crossroads. Let's contrast Hermes with something like OpenClaw. They represent two very different philosophies. OpenClaw is heavily configuration-centric.
Meaning static rules.
Exactly. Its boundaries are dictated by static rules in a sol.md file. And OpenClaw relies entirely on a public plugin marketplace.
Right, so if it needs to do something, it goes looking for a pre-written tool.
Yeah. Whereas Hermes is autonomy-centric. It relies on real-time, internal procedural tool generation. It creates its own Python scripts.
So if this were a company, OpenClaw is the broad project manager delegating tasks to different departments, and Hermes is the hyper-focused specialist in the lab actually building custom tools.
That is spot on. OpenClaw is for broad multi-channel routing and team management. Hermes is for deep specialist tasks and personalized continuous growth.
But as a user, I want both, right? Do I have to choose between the manager and the specialist?
No, you don't. And that's the beauty of it. The true power lies in the ultimate synergy between the two. It's a 3-part flow.
Okay, let's break that flow down.
First, you have the orchestrator, which is OpenClaw. It manages the complex project scopes, routes the tasks, and handles broad team communication.
Okay, making sure the big picture is intact.
Right. Then third, you have the specialist worker, Hermes. It receives the task parameters, executes the deep dive coding, self-debugs, and reports back up the chain.
But wait, you said it was a three-part flow. What's the second part? What's connecting them?
Ah, that's the bridge. The ACP, or Agent Communication Protocol. This is the unsung hero of the entire architecture. It allows flawless data handoffs between the orchestrator and the specialist.
Because if the manager and the worker aren't communicating perfectly, the whole project falls apart.
Exactly. The ACP ensures that absolutely no context is lost in translation. They aren't just passing conversational text back and forth, they're passing highly structured JSON payloads.
That makes a huge difference. Okay, so all this architecture and synergy sounds completely incredible in theory, but what does it actually produce for you, the user, out in the real world? Let's look at a concrete execution of this.
Let's talk about autonomous video generation. This is a perfect example.
Right, walk us through the process.
So the input is just a single text prompt from the user requesting a technical explainer video. That's it.
Just one prompt.
Yep. Then the process kicks off. Hermes receives the payload, and it autonomously writes the Python code required to trigger the Manim animation engine.
Oh, wow. I have to jump in here. Manim is incredibly complex. It's a math animation engine. Translating abstract visual concepts into strict Python for Manim is something human developers really struggle with.
It is notoriously difficult. But Hermes writes the code, renders the scenes, and then executes scripts to stitch the entire video sequence together.
And what's the final output?
A fully animated 1080p complex math and tech explainer video generated with zero manual editing.
Zero manual editing. Wait, really?
Absolutely zero.
That is just, it's mind-blowing. Think about how many specialized human skills it just independently executed. Coding, animation, rendering, editing, all with no human intervention.
Exactly. And that video example is just one output. We really need to look at the macro-level impact of having an AI that operates this way over months or years.
Right, because it's not resetting.
No. We call this the compound interest AI. It becomes an appreciating asset.
Because of the persistent memory, the sessions end, but the AI never forgets you.
Exactly. It stops borrowing external plugins and creates its own bespoke tools. As a digital co-founder operating 24/7 on your server, its capabilities expand exponentially over time.
It's like financial compound interest.
Exactly like that. Most software you buy, it depreciates, right? It becomes obsolete the day after you install it. Hermes represents a paradigm where the software actually becomes infinitely more valuable and more customized to you the longer it runs.
It's a completely new way of thinking about our digital tools. Well, to kind of recap our journey today, we've really moved far away from these amnesiac chatbots that need constant hand-holding.
Yeah, those days are ending.
We are stepping into a world of 247 autonomous specialists that actually learn your style and build their own bespoke tools from scratch. And listen, if you've enjoyed exploring the bleeding edge of AI with us today, make sure to hit subscribe and leave a like on this G2G video to support our journey from knowledge to wisdom.
And I'll leave you with this final thought to ponder. If your digital co-founder is operating 24/7, constantly evolving its bespoke tools and compounding in skill while you sleep, at what point does it stop being your assistant and start becoming the senior partner in your creative projects?
That is both terrifying and incredibly exciting. Thanks for exploring it with us. We'll see you on the next deep dive.